All right, now we're going to do number 16. They tell us ABCD is a trapezoid. So I'm going to go plot the trapezoid here. You should know how to plot points. That'd be negative 4, 1, or negative 4, negative 1, negative 2, 3, 3, 3, and 5, negative 1. Now, what does it mean to be a trapezoid? To be a trapezoid means that you have two parallel sides. So, for instance, these two sides are not parallel. I can see that by the picture. We call those legs in a trapezoid. But it looks like the parallel sides are these sides. So to be a trapezoid, two sides are parallel, the other two sides are not. So the first thing they say is determine the slope. And I do need to put my label on here. So that'd be label A. Oh no. I did not want to move that. Sorry about that. Take it right there. Okay, now I'm trying to put a text box. So this is A. This was B. That was C. I've used a picture of a graph, that's why I'm struggling here. And then the other one is D. So we're going to determine the slope. We're going to find the slope of AB, slope of BC, slope of CD, and of course slope of AD. All right, AB, rise over run. If I start here and I work my way to B, I go up 1, 2, 3, 4, 1, 2. So that would be 4 over 2, which equals 2. When I go from B to C, horizontal slope, if it's straight left and right, it's just 0. That's easy. From C to D, this is negative, and I go down 1, 2, 3, 4, 1, 2. So that'd be negative 4 over 2, which is negative 2. And then slope of AD, that would again be 0. So I found the slope of all four sides. Which sides are parallel? So I would say the parallel sides are I almost said AB. Not AB, very clearly not, is BC and AD. Now explain your reasoning. Why? Because they both have the same slope of, looks like 0. So they both have the same slope of 0. All right, now let's do one just like it. So you have a trapezoid. We have J is negative 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There's J. K is at 6, 2. 1, 2, 3, 4, 5, 6. 1, 2. L is at 1, 3. And M is at negative 4, negative 1. Okay, I connect the dots. I could do that. I guess we're going to do red. Now remember, to be a trapezoid, that means two sides are parallel, two sides are not. So I should probably, doing it again, label. So I got J. J would go here. I have K. K is right there. L. L is 1, 3. That'd be there. And M would go there. So I need to find the slope of each side. So let's find the slope of, and it doesn't matter where you start. We'll do JM, slope of ML, slope of LK, and of course slope of the last one would be KJ. Equals. All right, let's start at J. J to M. Remember, anything that's straight vertical, we call that undefined. M to L. Rise over run. This is positive. 1, 2. I'm going to use a different cursor. 1, 2, 3, 4. So 1, 2. I can't get all these boxes to stay away. Okay, there we go. 1, 2, 3, 4. 1, 2, 3, 4, 5. So that's 4/5. Now we're going to go from L to K. Down 1. 1, 2, 3, 4, 5. And this is negative slope, negative 1/5. So far, none of them are the same. And then J to K, let's see, that would be 1, 2, 3, 4, 5, 6, 7, 8, right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That'd be 8/10. Now 8/10 reduces to 4/5. So I just proved that ML and KJ are parallel. So base, which sides are parallel? I would say ML and KJ are parallel because they have the same slope of 4/5. All right, now this is one of those where you select the statements that must be true if this is a parallelogram. So assume that this is a parallelogram. What has to be true? Let's just go through the options. The first one says that G plus D is 180. So G plus D is 180. And that is true. In a parallelogram, consecutive angles are supplementary. So that is true. F plus G is 180. So F and G are 180. Yes, that's true. Consecutive angles are supplementary. Next one, that G is equal to E. That's true. In a parallelogram, opposite angles are congruent. DG is parallel. Remember that symbol is for parallel. So is DG parallel to EF? So here's DG. Here's EF. Are those parallel? Yes, it's a parallelogram. Those sides have to be parallel. G plus E is 180. Is that true? No, they're not. They don't add to 180. They're actually equal. So that one doesn't work. Let's see. DE. Where's DE? DE is congruent to GF. Yes, that is true. In a parallelogram, opposite sides are congruent. D equals E. D equals E? No, that's not true. Consecutive angles are supplementary, not congruent. So it's everything is true except this one. I went the wrong way on that one. So not this one and not that one. Everything else is true. Now let's talk about, this is a trapezoid because DC and AB are parallel, but the other two sides are not parallel. So these have the properties of a trapezoid. And it also has the properties of an isosceles trapezoid because they have, those two are the same. So what do we know about an isosceles trapezoid? We know that the base angles are the same. So if this is 101, then that's 101. Okay, so what's the measure of angle D? 101 degrees. Now, you may be asking, how do I find B? Well, these two are supplementary. And so I would do 180 minus 101, and that'd be 79. But because this is isosceles, this would also be 79. So if they asked for A or B, that's how I would get the rest. All they asked for was D. Find the measuring angle Q. They don't tell me it's isosceles. They say this is parallel. This one clearly is not. But I do see that they're both 8. So they are isosceles. So this one's turned a little bit. So these are not the base angles. These are. So if that's 110, that has to be 110. Okay. But they wanted Q. So we know that in any trapezoid, isosceles or not, those two add up to 180. So that would be 70. So what's the measuring angle Q? 70 degrees. What's the measuring angle K? Well, if that's 80, then we know that this is 80. And also, we know that those two add up to 180. And this is only true if this is isosceles, which it is. And also in isosceles, opposite angles are supplementary. So that's another thing we could use. Next, classify this figure in as many ways as possible. So what I notice, looking at this, is that the symbol says all sides are equal, and all the angles have that little square, so it's 90 degrees. So what this means is we have what's called a square. That is the most specific name. But all squares are also rectangles, and all squares are also rhombi. And squares and rhombi are all special types of parallelograms, but all parallelograms are quadrilaterals. So you could actually call this any of these different ways. Okay? So the answer here would be A.